continuing with section 7.1. In the last video, we saw how to simplify given trigonometric expressions. Now, the major concept in this section is to be able to use our simplification techniques that we did in this exercise 1 or in this previous video to verify trigonometric identities. Just for example, verify the identity. So what is an identity? Identity is an equation in which left hand side and right hand side are same, although they don't look same, but they are actually same. So we have to verify them. We have to show why we are saying that they are the same, or why we are saying that this is the trigonometric identity. So, for example, here you have one identity. So this is looking like whatever, and then on the right side we have 1. So it means this, whatever this gibberish is, this is equal to 1. So we have to now show, that this is equal to 1. So the way I do this, so I call this the left hand side and I'll call this the right hand side. Okay. So since the left hand side is more complicated, we should start with the left hand side. So always start with the complex side. So I can go like left hand side equals, so you can write down tangent of V plus cotangent of V times sine of V into cosine of V. So now what can we do here? What would you do if these were numbers or they were just variables? What is the common sense or common observation tells you? It kind of gives you, pushes you to distribute. So multiply this with each quantity inside. So when I do that, I get tangent of V times sine of V times cosine of V plus same thing, cotangent of V and then sine of V times cosine of V. So now I say, okay, there is tangent and there is cosine sine, so I have to convert it into sine. So this becomes equal to, so I am just taking the left hand side and I'm equating is taking is equal to. So sine of V over cosine of V times sine of V times cosine of V. That is the first term, plus the second term looks like cosine of V over sine of V times sine of V into cosine of V. So now you notice that these two cancel out. And in the second expression, these two cancel out. So what are we left with? The first term becomes sine square V and second term is cosine square V. And what is that? That is equal to 1. So is equal to right hand side. So we have shown that if we start with the left hand side and we show that what we are getting is the same thing as the right hand side. So that's how we have proved the identity or verified the identity. So the goal of these problems is to show that the equations are valid. Okay, that's what I was mentioning, that we have to show that the left hand side and the right hand side are same. So it means the equation is valid. By simplifying the expression on one side of the inequality to match the expression on the other side of the inequality, or by simplifying both expressions one by one to match one another. Sometimes it might happen the left side is complex and the right side is also complex. So we can start with the left hand side and work our way to simplification without having a clear goal in our head, like where we are approaching. Because in this example that I just showed you, well, our right hand side is 1. So our goal is to get our left hand side to equal 1. But in some cases it could be that the right hand side is something which, when we simplify the left hand side, it doesn't look like what we have on the right hand side. In that case, we should now take the right hand side and try to simplify that. If both sides give us the same expression, or simplifying both sides separately, we arrive at the same answer, then it means we have verified the identity. So note here, these are not equations. Although there is an equal to sign, like this identity, so the identities that when we verify identities, although there is an equal to sign in the identity, these are not equations. It means we cannot add, multiply, subtract, or divide both sides by something. Okay? You cannot move things from one side to another side. We are not solving anything here. We are just simplifying. Simplification will require the use of identities, common denominators, multiplying by the conjugate, etc. Now, clearing fractions is not a way to simplify. It is a way to solve, and that is not what we are doing here. Okay? So let's see. First, so this is an identity now. So we have to show that you can see this is the complex side, this is the simple side. Now from here, getting here is not that easy or not that obvious compared to getting from here to this side. So although not too bad, we can get from right hand side to the left as well. But so here, from the because on the left hand side you can see we have tangent theta and secant theta. On the right we have sine theta. So this kind of gives us a hint that start with the left hand side and convert the tangent and secant into sine and cosine. So tangent will be sine of theta over cosine of theta, whole divided by 1 over cosine theta, which can now be written as sine theta over cosine theta times cosine theta over 1. So cosine and cosine cancel out, you end up getting sine of theta, which is the same thing as you have on the right hand side. So we are done. Okay. Now some students would do it like this. Let me show you. They will start with the left hand side. So we have tangent theta over secant theta is equal to sine theta. So they will simplify the left hand side. The same steps that I have done, you can carry those. But they will keep writing the right hand side with it, which is okay, but not professional. Because then you are already saying that they are equal, but whereas you have to verify, you have to confirm. So I would suggest that if you are doing this, then maybe put a question mark in each line or on the equal to sign, that we are checking, are they really equal? So now doing the step of converting the division into product. So once you get the same thing, then you don't have to put the question mark. So we came out that sine of theta is sine theta. So therefore you can say now, you can say left hand side is equal to right hand side. So we are done. Okay. So this is another way of doing it. Okay, now looking at the next part B. if you can think of something. The left hand side is complicated. Left hand side is equal to sine square t plus cosine square t plus tangent square t. So what should we do now? This is the thing. See, if you have enough practice, and if you have those Pythagorean identities memorized, this is going to be very, very simple. But if not, and if you try to convert a tangent into sine over cosine and go through that whole long process, taking the common denominator and all that, it will take you much longer time to do the problem. So by memorizing the identities, I mean to say that we know that sine square t plus cosine square t is equal to 1. So I can replace this by 1. Okay, and then plus tangent square t. Now what is 1 plus tangent square t? So if you have memorized the other Pythagorean identities, then this is the second one. So this gives us equal to secant square t, and which is our right hand side. So it becomes so simple. Again, but let's say you don't know, you forgot that 1 plus tangent square t is secant square t. Then what should you do? You can do it like this, is equal to 1 plus sine square t over cosine square t. Take the common denominator, so you get cosine square t plus sine square t over cosine square t, which is equal to 1 over cosine square t, which is 1 over cosine of t whole squared, which is equal to secant of t whole squared, because this would be equal to 1 over cosine of t whole squared. So you can write it as secant of t whole square or secant square t. So again, this involves a little bit more work. So if you have the identities as many as possible memorized, this will be these will come easy to you. And because if you have them memorized, if you know your identities, then when you see some expression, you can relate it to, oh, this looks like that identity, or one side of the identity, so I think I can use that. And then you try, and you might be able to get the correct answer. So I am just going to leave it like this one. Okay. By the way, there is a precaution note that this does not mean that you can say sine of t plus cosine of t is equal to, so this is not 1. Okay, sine of t plus cosine of t is not equal to 1, because you cannot square root it and say that I get sine of t plus cosine of t, because remember, if you have a square plus b square, square root is not a plus b. And if you think it is, then check this. Is this true? If you have 3 square plus 4 square, is it equal to 3 plus 4? Check this. If it is coming out true, then you can write a square plus b square, square root is a plus b. But you will see that you do not get them correct, right, equal to each other. So that why you cannot do the square root. Okay, looking at this part C, this is a little bit think this is something we have seen before, but anyhow, so you can see there is a sine, cosine, and then we have cotangent and cosecant. So what does that suggest? That I convert the secant and cotangent into sine and cosine. So I get left hand side equals to sine of alpha over 1 minus cosine of alpha minus cosine alpha over sine alpha. That's the cotangent. And now I can do the common denominator. When I do the common denominator, I end up getting 1 minus cosine alpha times sine alpha, and on the top sine alpha times sine alpha minus, okay, I need more space here, rewriting. So LHS equals, so we have sine alpha over 1 minus cosine alpha, and then minus cosine alpha over sine alpha, which is equal to, taking the common denominator, so this sine alpha into sine alpha minus cosine alpha into 1 plus 1 minus cosine alpha. So multiply out, do not multiply out the denominator. So on the top I am getting sine square alpha minus cosine alpha plus cosine square alpha, which can now be written as sine square alpha plus cosine square alpha minus cosine alpha whole divided by 1 minus cosine alpha into sine alpha. Top, you can see the sine square alpha plus cosine square alpha is 1. So 1 minus cosine alpha whole divided by 1 minus cosine alpha times sine alpha. So this and this cancel out, and we are left with 1 over sine alpha. But what is 1 over sine alpha? It is equal to cosecant alpha. Okay. Again, now let's say, so we are getting from here, we get 1 over sine alpha, and you say, okay, now I cannot go further, right? This is the simplest form I could have. But now you might say, okay, so what do I do now? So then the case goes that you can now, if you remember that 1 over sine alpha is cosecant alpha, you can just go one more step, write it is equal to cosecant alpha, which is equal to the right hand side. But if not, then you have to leave it here as 1 over sine alpha and go to the right hand side. Now pick the right hand side, RHS equal to 1 over, sorry, it's equal to cosecant alpha, but cosecant alpha is 1 over sine alpha. So now you see we had 1 over sine alpha there, we have 1 over sine alpha here, therefore we are done. Okay, looking at the next identity. Okay, I'll give you a few minutes to you, and then I'll come back to the next video to check if you got this one.